So let me talk about even functions. Even functions. So even function is the following. Any even function, if you graph it, it looks like this. It's a complete mirror image on the y-axis. So let's say it looks like this on the right side of the y-axis. On the left side, it will look like this too, although I'm not doing a very good job. Okay, but it has to be a complete mirror image. So how do you write this algebraically? Look, no matter what you pick, so let's say that's 8, right? Or let's say that's 2. The y value you get for 2 has to be also the same for -2. If you plug in 5, the y value you get also has to be same for, this graph is not very good right now. Okay. So this has to, well, this has to be a lot flatter. Okay. This has to be -5. Is that okay? Let's use this instead. So the point I'm trying to make here is that no matter what x value you pick, right, the opposite x values will give you the same y value. Okay, look. See this? If you go across, so that was 2, it'll be -2. Okay, it'll hit right there, and it'll be -2. It'll be like that for every single x value. And you write that this way: f at x is equal to, if this was x, what is this? If that was x, this will be, yeah, so it's equal to -x. If you see this, you have to know that it's this. It's a mirror image on the y-axis. Okay, I mean, if you look at a picture, well, everybody will go, oh, it's symmetric. But a lot of times you forget that if you see this, it means this. So we call that an even function. Now, in the last class, we actually had an example like that. We had this, right? Let me call that f at x. Let's see what happens if I plug in -f of x. You get this, which is this, which is the same as this, right? Right, -x, positive x, it's the same. That's why the graph looked like that. The graph looked like this, a mirror image. Okay. And this is true for anything that you can do this on. Anything that you can show that these two are exactly the same thing. Okay. Another easy example. X squared. You guys know what x squared looks like, right? Look, same. Right? If you plug in -x in here, you get x squared, same thing. Okay. So that's how you show it. F at -x is equal to f at x, then you say it's an even function. Okay. So we have this procedure here, right? Because sometimes you don't know what the graph looks like. You don't have enough information. But at least through algebra, we can tell it's symmetric on the y-axis. Okay, so this is a graph that we don't know how to graph. Okay, we can't sketch that. We haven't learned it yet. But we know how to substitute in -x. You simplify this and you get x squared plus x to the power 4, don't we? Isn't that exactly what we started with?